All right, grade 11s, welcome to your Analytical Geometry lesson 3, and I hope you are ready and you are willing to go through this part. We'll just be talking about the gradients of perpendicular and parallel lines here, as well as some collinear points. So firstly, we have to understand what that is first, and then we can see what happens after. So here, look at what we've got here. Just a second. Okay, so we have gradients of perpendicular and parallel lines, and here the collinear points are down here. So let's first of all get into these relationships fast. Okay, so to start with, let's talk about the perpendicular lines. You are seeing what we've got here. The perpendicular lines, this is the relationship that we already know. So if two lines are perpendicular, they look like this. They are at 90 degrees to each other. So let's just call this line here, let's just call it line 1. So if you calculate the gradient of line 1 and the gradient of line 2, what we know about this is that m1 times m2 should actually give us -1. You already have this one in your notes over here. So just remember they will be at 90 degrees to each other. And the gradients will be the negative reciprocal of each other. So let me just say, for example, I had a line like this, and I say that the gradient of this line happens to be 2/3, and for some reason I actually have another line that is perpendicular to it, 90 degrees to it. So the gradient of this line will be the negative reciprocal of the first one here. So to get the negative reciprocal, you just invert the fraction. It was 2/3, now it's 3/2, and then you change the sign. So that is all there is to it. Or you can use the formula m1 times m2 is equal to -1. You know exactly how to do those things. So just to check if you're following, let me just say if our m1 was equal to, let's say a half, what was going to be our m2? You invert, and when you invert it to be 2/1, it should just be 2, and then you put a negative. It's that simple. So that is the relationship we have for perpendicular lines. The interesting one is for parallel lines. Well, if lines are parallel, just like this, we already know that these ones will have the same gradient. So the gradient of this line and the gradient of that line will be exactly the same. So that is what we know about parallel lines. Very simple to remember. Well, the one thing that's interesting, perhaps, maybe you've forgotten that from your lower grades, if you've got collinear points, it just means that they lie on the same line, really. So if they lie on the same line, there are some things you have to know. How do you prove that points are collinear? Let's take, for example, the one that we've got here. Well, we have A, which is at 2 and -2, then B, and then C over there. Why don't we just put them on a Cartesian plane and see what happens over there? Let me do this. If I put them there, for example, and then I try to sketch those points, let's see what will happen. So if I put 2 and -2, I should perhaps have that point over there and call it 2 and -2. And then if I am to sketch, this will be A right there. A, and then let's say B, 1 and 1. A point that is 1 and 1, let's put it over there. Say 1 and 1. That would be coordinate B. You're putting it on a Cartesian plane where your y and your x-axis is over there. Well, let's get the coordinate of C, and it is -1 and 7. I'll just put it right here and say this is C. Well, if these are collinear, we are practically saying that there must be a line that passes through all 3 points, a straight line that passes through all 3 points. And if there is a straight line that passes through all 3 points, that line is not very straight. Well, what we should know is that the gradient should not change at any point. So I'm going to try that again. Okay, let's try to put a line that passes through all 3 points. Well, let's move that point to that place. It should be fine. So using a freehand here, oh, that's the best we could do with a straight line. So we are saying these are collinear. That's to be collinear, to lie on the same straight line. But how can we prove that there is actually a straight line passing through A, B, and C? All you have to remember is that if points are collinear, the gradient between A, B, if you calculate the gradient here, right here, it should be the same as calculating gradient over there between those 2 points, which would be the gradient of BC. And it shouldn't become any different if you calculate the gradient between actually this point and that point over there. That would be the gradient of AC. So that is how we know that the points are actually collinear, if these 3 gradients are the same. In fact, all you need to do is to calculate any 2 that you've got, and if you calculate any 2, you should be able to find the correct gradient. So let's go ahead and calculate the gradient of AB here. Let's see if that will be the same. So in this situation, we want to prove that these points are collinear, right? So I'm going to go ahead and say 1 minus minus 3. We already know how to calculate gradient, so I can just go at any pace here. And then we are calculating the gradient between A and B. So I'm sure you're noticing why I'm saying 1 minus minus. It should be a 2 actually. So this is kind of misleading. Okay, so that's a 2. Right, so it's 1 minus minus 2 before we go too far. Okay, use these ones that are here. You can easily see them over here. So divided by 1 minus 2. As you can see, when you calculate the gradient of AB, you would definitely just get your negative 3 over there. Well, that's good. We have the gradient of AB. Let's see if we can calculate the gradient of BC then. And let's see if it is the same. Well, take B and C, these ones. So I think if I just say 7 minus 1 divided by, this will be negative 1 over here, negative 1. So divided by negative 1 minus 1. So as we can see, we seem to have a 6 divided by minus 2, and it is also going to simply be negative 3. So it does look like we are managing after all. So if we prove that the gradient of AB is equal to the gradient of BC, we have already done enough to show that ABC, those points are collinear. But just to emphasize on what we are doing here, I'm also going to just calculate the gradient of AC here. So to calculate the gradient of AC, I'll just say 7 minus minus 2, and all divided by negative 1 minus 2. So you can see this time around, we have 9 on the numerator, 7 plus 2, divided by minus 3. So we will definitely get negative 3. So we have established the fact that the gradient of AB, we have noticed, it is equal to the gradient of BC, and which is definitely equal to the gradient of AC. We can see it's all equal to negative 3, and negative 3. Therefore, we can say that, therefore, A, B, and C are collinear. That's being collinear right there. Okay, so now that we know this, why is it important? We just want to use this fact that we know this to calculate important sums, such as this one. Well, you usually will be given, say, what we've got here. You have A, B, C, and D, okay? It's just that you don't have X at C here. You can see you have an unknown here at coordinate C. But you would like to calculate that unknown if you were perhaps told, say, for example, that AB is parallel to CD for number A. Well, what we know is that if 2 lines are parallel, the gradient of AB is going to be equal to the gradient of CD. So that's what we know for parallel lines, isn't it? So you have to remember that. That's all you have to remember. And if you remember that, you can easily calculate that unknown. So if I look at A and B now, let's calculate the gradient of AB. I'm not going to waste time. I'll just say 7 minus 4 divided by, I'm looking at these 2, and then it will be negative 1 minus 3. That should be equal to the gradient of CD. And the gradient of CD can be calculated by saying, I take these as my 2's here and take these ones as my 1's. So I'm going to say negative 1 minus 8 divided by x minus 1. This is what I know is true for A. When lines are parallel, the gradient is the same. So this one should be easy to simplify. There is a 3 and a negative 4 at the bottom, so I'm just going to write it as negative 3 over 4. And then this is going to be negative 9 over x minus 1. So in the future, let's just think of the gradient of AB as negative 3 over 4. Well, from here, okay, you're noticing that we may have to put these a little bit down so we don't forget that we have them. Well, since our purpose here is to actually calculate x, at this point I'm just going to cross multiply. Negative 3 will multiply with x minus 1, and negative 9 will multiply with a 4. That should be easy for us to do. Okay? So let us quickly do that. Should be negative 36. All right. So as you can see, if I now take this 3 to the other side, do you see that here I have 3 in my head but not on the board? So negative 3 times negative 1 should be positive 3 here. Okay? Now if I take 3 to the other side, now I will see that I will now have negative 3x happens to be equal to negative 39. So though that is the x actually will go about, 13 times. So we have managed to calculate the value of x if AB and CD are parallel. We just do that. So that is all that we have to do. Just knowing that this exists, we must help us. So in this situation, let's just write again. Let's write down the coordinates of A, B, C, and D. We may need them, or let's have them here quickly. I'll just do that quickly. So A, we are noticing that A happens to be 3 and 4, okay? And then B is negative 1 and 7. And then C is the unknown, which is x and negative 1. And then D, let's put it here quickly, as 1 and 8. So we are saying that let's still calculate this time around. Let us calculate the unknown if we were told that line AB is perpendicular to CD. So what do we know about lines that are perpendicular to each other? Well, I think you're saying it. So you know that the gradient of AB multiplied by the gradient of CD should give you negative 1. That is the statement you know. So it doesn't matter what happens, as long as you're using this equation, you will get there anyway. So let's go ahead and show that this is true. We use what we know to calculate what we need. Did we calculate the gradient of AB before? No need to calculate it again. Notice we have it over here as the gradient of AB. We already know that it is negative 3/4. Okay? And the gradient of CD, did we also calculate that? Let me see. Oh, interesting. We also calculated the gradient of CD. Notice it is minus 9. It is right here as minus 9 over x minus 1. That is the gradient of CD. So let's put it here. What we know is that this should be equal to negative 1. That is what we know from what we learned. Since they are perpendicular, their gradients, the product of their gradients should be negative 1. So it should be easy to see. Okay, the text keeps jumping around. I hope it's not annoying you there. Okay, good. So here we have this. Let's now calculate what we need. So firstly, I'm going to divide both sides by minus 3/4. So I'm going to have that negative reciprocal. You know, if minus 3/4 is your other gradient, you know that the other gradient should be equal to 4 over 3, isn't it? So you can either do it that way, or you can really just say negative 1 divided by minus 3/4. you should get to your 4 over 3 in no time at all. And cross multiplying here will be simple. The 4 will multiply with the x minus 1, and 9 will multiply with 3. So let's go ahead and do that. So 3 should multiply with negative 9. So let's write that down. Let's simplify it. Let's not repeat that again. Should be negative 27. As you can see now, at this point, you can just take 4 to the other side, and you'll realize that when you say plus 4 there, you'll get negative 23. So I'm going to say your 4x is going to be equal to negative 23, and in this particular situation, your x is negative 23 over 4. Well, that is a value that you got. If these lines were perpendicular, we were going to get the x value as negative 23 over 24. Okay, good for us. You know what I'm going to do? I'm going to take this question again, and we are going to answer it quickly together for the last question. Well, let me take those points with me. Okay, let's take down not that, but that. Let's have it down here. Okay, so here is what I want us to do. I want us to get B, C, and D. We want to get the value of x rather. We want to get this value here. If B, C, and D are collinear, from what we talked about, if these 3 points are collinear, B, C, and D, the gradient between B and C should be equal to the gradient between C and D, which should also be equal to the gradient between B and D. So you choose the one that's easy for you to calculate. So don't just pick where there are unknowns. As you can see this time around, I have the coordinates of B. Are you seeing that? I have all coordinates of B, and I also have all coordinates of D. So calculating the gradient of BD will be very simple. And what else do we have? We already calculated the gradient of CD before, do you remember? So at this point, I am just going to use these two. I'm going to just say, well, the gradient of CD, since for collinear points, that is true. I can just equate the gradient of CD to the gradient of BD because they are collinear points. And we said the gradient of CD, we calculated it up there as negative 9. Are you still seeing it over here? I'm looking at it over there. It's negative 9 over x minus 1. Or you can start calculating it. Really, the points are there. And calculating the gradient of BD is going to be simple because you have to say 7 minus 8. I'm using the coordinates. And we have to divide by x2 minus x1, which is just this. So at this point, we are ready to simplify. Okay, and 7 minus 8 will be known to be negative 1 and negative 2 at the bottom. So it does look like we will just have a half like that. Then that is the step where we are actually expected to cross multiply. And if we cross multiply now, we should be able to get x minus 1 is equal to negative 18. And as you can see, this is how you get your x of negative 17 at this point. So you have managed to calculate the unknowns using the fact that you knew that they were collinear points, they were perpendicular lines, and they were parallel lines. So that is how you apply that knowledge. All right, so let's go ahead and use some more questions to get used to this information. Like, for example, here. If you look at the top there and you look at how these questions are phrased, hope you can see them. So let's try to make them a bit bigger. Okay, I hope you can see them clearly now. So look at A there. You see you have a point that is passing through -4 and 3, which is perpendicular to that. So you want to determine the equation of the line. And determining the equation of the line, we did that one already yesterday. Must have been a few lessons ago. And that was y is equal to mx plus c. And we also had another way of doing those straight lines, which was y minus y1 is equal to m into x minus x1. That was also the equation of a straight line. So what we also know is that for us to calculate the equation of a straight line, we will need to first of all determine its gradient, and of course we need at least 1 point to get the c value. So in this situation, that statement at A is it's actually giving us the idea of how to get the gradient. The 1 point that we need is over here. So what are we going to do? So firstly, let's take that line which is perpendicular to our line. So it is 2y is equal to 3x plus 6. So we have to first of all know the gradient of this line. And to do that, you can just divide by 2. And as you can see, it will be 3 over 2x, and 6 divided by 2 is 3. We are interested in the m part of this. So as you can see, the gradient for this one happens to be 3 over 2. So it is the m1 here. It is 3 over 2. So in this situation, we're talking about perpendicular lines. So since they are perpendicular lines, our line should now have a gradient of the negative reciprocal, which will be -2/3, isn't it? So it means if I want the equation of this line for A, it will be -2/3 x, I'm substituting in there, plus c. And then I just have to substitute -4 and 3 into this equation. That way I'll be able to get the equation perpendicular to this given equation and passing through this point. Okay, in place of y, do you see that I'm putting 3? And in place of x, I'm putting -4. So quick, let's get the c value. Well, this is 8 over 3 over here. If you multiply those two, you get 8 over 3. So you just have to say 3 minus 8 over 3. Okay, so I'm getting 1/3. So I hope you got exactly the same one as well. So as we can see in this situation, the equation of our straight line that we got will now be y is equal to -2 over 3x plus 1/3. That will be the equation of the line for A. Very simple, if you know what you're supposed to be doing. Okay, so I am also going to talk about B now. So for us to understand B better, I'm going to have to just drag it with us down. Let's drag the question down for a second there and create a bit of space. All right, so look at this. Now for B, all we need to do now is to find the equation of a line that is passing through this point given to us, -8 and -1, but parallel to this one. So if the line is parallel to a line called x minus 2y plus 2 is equal to 0, you first of all have to establish what this gradient is. So it might take a while, this one, but let's do it. It will be -x minus 2, isn't it, like this? And if you divide now by -2, the gradient here, with one equal sign, will be -1 divided by -2. I think you're seeing how that is going to be 1 over 2. And then -2 divided by -2 will be +1. So I managed to rewrite this equation given to us in the form that we can easily recognize, in this form. So this way I have managed to see how my gradient is actually equal to a half. And because these ones are parallel, our M2 is also going to be equal to a half, because parallel lines have the same gradient. So if I want the equation of this straight line, I'll just go straight to saying, well, y is equal to half x plus c. And all I need is that coordinate, if we still have it, that is -8 and -1. We put it there, and let's substitute it into these coordinates. This is malfunctioning. Okay, okay, let's just substitute. Just try to make space here. So it's -1 here in place of y, and then in place of x, let us put -8, and that will give us what we're looking for. So this is actually just -4 here when you take it to the other side to say -1, it will be +4, isn't it? So I believe it should be +3, which should leave our equation as a half x plus 3. Okay, let's write that one down. Easy, really, simple. Well, now, to wind up this lesson, we have creative type of questions that I want us to do. I want us to just determine the equation of CD in the situations that I'll provide for you. So let's look at this first one for starters. So if you look at this diagram that I have here for you, I want us to be able to determine CD here. So let's do it. Let's put it at a place where we can easily see everything. Okay? So I want you to determine the equation of this line CD over here. Okay? Let's rather highlight it in red then. This line CD. As you can see, it is perpendicular to AB. So getting its gradient is not going to be a problem. To get M, and getting C is not going to be a problem as well, especially if we have that. But I think you're noticing that to go to wherever we want to go, we may need to calculate the gradient of AB. At least we have two coordinates, so we can easily calculate the gradient of AB. So I'm going to go and say 4 minus minus 2 divided by -2 minus -6. So use your calculator or your good head and give us the gradient of AB here. It does look like there is a 6 on the numerator, and -2 plus 6 will be a 4. So 6 over 4 should be some 3 over 2 perhaps. Okay, that will be 3 over 2, correct? So if that is 3 over 2, the gradient of AB is 3 over 2. What is the negative reciprocal of that? I think you're saying the correct one. So the gradient now of CD that we want will simply be the negative reciprocal of this, which is -2 over 3. You can show the formula M1 times M2 is equal to -1. Really, you can go ahead and do that. So substituting into the equation of a straight line, I'm not going to waste your time. So let's substitute these coordinates D into this equation. So I'm saying -1.5, that's -3 over 2 right there. And our x happens to be 1. So let's go ahead and find the C value at this point. Okay, go ahead. Okay, I am getting 5 over 6, -5 over 6 actually, so I hope you've got the same solution here. It's -3 over 2 plus 2 over 3. You should get -5 over 6 over there. So our equation for this one will simply be -2/3 x minus 5 over 6. So in fact, there are a few questions I would like for you to find to determine this equation of CD. So I want us to play around a bit more and get the equation of CD on these problems here as well. So as you can see, they are not challenging, so you can really do them first and then come back and see how I solved these things, okay? So you can pause and work them out first. Well, in this situation, remember the equation we want is the equation of CD. But in this situation, you can see how it is parallel to AB here. So since it is parallel to AB, you can easily, first of all, calculate the gradient of AB, and after you calculate the gradient of AB, then you can just equate it to the gradient of CD. So let's go ahead and do just that. So gradient of AB is simple. I'm going to say 3 minus 5. I'm substituting into this formula. In case, we maybe have not mentioned the equation to calculate the gradient in this lesson. So in case you do not remember, this is the formula for calculating gradient. So I'm just substituting into that formula. Well, divided by 2 minus 2. So the gradient of AB this time around, it does look like there is an 8 on the numerator and a 4 on the denominator. Okay, so it should be 2 actually. So I'm going to get 2, and from what we know, this will be equal to the gradient of CD as well. So if I want the equation of CD, I'll just have to say 2x plus c and substitute a coordinate. Let's go ahead and substitute any coordinate. I like, oh, don't forget, we are not trying to get the equation of AB, we are trying to get the equation of CD. So we have to substitute a coordinate that is on CD. So let's go ahead and substitute that in there. I'm going to say minus 3, and in place of x, as you can see, I'm putting negative 5. And it should be simple to say negative 3. This is negative 10, right? It's negative 10 here. So when you take it to the other side, it should be negative 3 plus 10, which will be 7. So our equation will be 2x plus 7. I'm sure you got that one right. Good. Let's go to the second one. Same thing. But there is one little catch about that question. That question is saying you have to find CD, but it does look like there was no coordinate given on CD for you to use to calculate C. But it looks like there was no coordinate given, but really D, we can easily calculate D. Remember, the midpoint of a line is x1 plus x2 divided by 2. And then we have y1 plus y2 divided by 2. That is how we calculate the midpoint of a straight line. And we can see that D here happens to be that midpoint that we are looking for. So we have to calculate the midpoint of PR in this situation. So we just add negative 2 and 6 and divide that by 2. And then we add 5 and negative 1. So it will be 5 plus negative 1, so I'll just write 5 minus 1 here. And you divide that by 2. So the coordinates of D will be easy for us to see. So that should be 4 over 2, which should be just 2. Okay? And then the other one, if you look at it, 5 minus 1, it will also just be at 2. So now at this point, we have the coordinates of D. So we are going to use those coordinates now to calculate the C value. But before we do that, why don't we calculate the gradient of PR, since we already know that PR is perpendicular. There's a 90 degree here between PR and CD. So since it is possible to calculate the gradient of PR, let's go ahead and do it. I'm going to say it's 5 minus 1, negative 1 there, divided by negative 2 minus 6. Well, as we can see, it is going to just be negative 3 over 4 eventually. Okay, so it's a 6, and then at the bottom it is negative 8. So you can see that it simplifies to negative 3 over 4, isn't it? So if the gradient of PR, this PR that we've got here, if it is equal to negative 3 over 4, what would then be the gradient of our red CD? So the gradient of CD now is just going to be the negative reciprocal of that. And that will be 4 over 3. You change the sign. So we are done, really. We will just have to substitute. Let's carry on. To get the equation, it is now going to be 4 over 3x plus c. And to get the c value, you substitute a point that is on the straight line CD. and that is D right there. So go ahead and substitute D. It means in place of y you put 2, and in place of x you still put 2. That should give us a C value that is simple. So 2 minus 8 over 3. Solve that one quickly. It's a 2 minus 8 over 3. I'm getting minus 2/3. Okay, so the equation thereof is now simply going to be y is equal to 4 over 3x minus 2 over 3. So that is the equation of C, as you are noticing over there. Well, it's easy to calculate these equations, isn't it? So I also just thought it would be fair to give you this one as dessert. Some dessert, people, some dessert right here. I still want you to calculate the gradient of CD in this exercise. And CD, as you can see, again, it is parallel to AB. But as you can see, we talked about parallel lines. But in this situation, can you see that the gradient, you cannot really calculate the gradient of AB here by using 2 coordinates maybe. You have to use this angle of inclination. So I like this question because we know that to get the gradient of AB, now we have to use that formula which I said, M is equal to tan theta. So if you still have it in your head, good for you. So it will be tan of this 153 going on and on. So if you calculate that one, you will notice that the gradient of AB, let's use our calculator quickly to calculate the gradient of AB. Well, I'm getting negative 0.5. So yeah, let's round it off to negative 0.5. And well, I'm going to write it as minus a half. You see, negative 0.5. So since these two are parallel, it means if I want to calculate the gradient of CD, it should also be negative a half. So my equation will be very simple to find because I substitute it into the equation y is equal to mx plus c, and then it should look something of this sort. So all I need to do now is to substitute any coordinate on CD. And luckily for us, we have that hidden coordinate there. And that coordinate is negative 2 and 0. So we're going to substitute it and have no problems whatsoever. So here we are. I'm going to put negative 2 here to calculate C. So it appears as if that will be 2 over 2, that should be 1. If you take it to the other side, it should be negative 1. So I'm getting a C value of negative 1, which will leave me with the equation of CD as negative half x minus 1. Okay, so you see, this is what I wanted you to do in this lesson, just to appreciate how collinear points, how parallel lines, and how perpendicular lines may be asked in questions, just to be clever about it. Okay, I hope you understood this lesson, and as usual, I am thanking you a lot for watching this video.